Hello, algebra students. Mr. Lawrence here, and we are going to do a little factoring review. We've learned a lot of different types of factoring in a very short time. Let's see how this is going to work. Well, first of all, we've got the GCF, right? By the way, you should always look for a GCF first. Remember in the video the other day, I was pulling GCFs out of trinomials and made them easier to factor. Always look for the GCF first. Okay, I'm looking for the GCF here, and I see what? A 5 for the coefficients, right? For the variable, for the x, it's going to be an x squared is common to all three terms. And it looks like only a y to the first is common. So now I'm going to divide each of these terms by 5x squared y, right? And that'll tell me what's left inside. Okay, 5x squared y. And so I will get 3, and then I'll get y to the 7th. I'll get a negative 2, x squared, and then a y squared. And then a 5 with an x cubed. And there we go. Factored. Easy as pie. All right, this one here, grouping. Remember, I can rewrite the order if I choose to. I think we'll move this up a little bit. Um, and I do think I want to rewrite the order. I think I'm going to rewrite it as 6x squared plus 18x plus 10xy plus 30y. I could have grouped it the way it was written because there was a GCF with each pair, you know, the 6x squared and the 10xy and the 18x and the 30y. But in this case, it just seemed to stand out to me that I should group it with these terms together. Not wrong to do it the other way. All right, I'm going to pull out a GCF with the first quantity. I'm going to get 6x, which will be x plus 3. And then here I'm going to pull out a 10y, looks like. And I'll be left with an x plus 3. Look at that, I've got an x plus 3 in each quantity, in each group. So I'll have an x plus 3 to pull out, and I'll be left with a 6x plus a 10y. And there you go. Okay. Factoring trinomials here, the first couple, the lead coefficient will be 1. All right, so 1 times 16. I need two factors of 16 that add to get 10. Now, if you can see those factors right away, like if you can see that, hey, 2 times 8 is 16, 2 plus 8 does equal 10, you can go ahead and do it. X squared plus 2x plus 8x plus 16. You can go right to it. You don't have to list all the factors. You list them when you can't see them. All right, we're going to pull out a GCF. X times the quantity of x plus 2. Pull out an 8. Have x plus 2. Looks like an x plus 2 is common. And we'll be left with an x plus 8 in a quantity. And there we go. Yeah, I'm going through these pretty quick, but it should be review. All right. Oh, I wanted to change this one, silly me, to a negative. Okay. Again, I need 1 times 27, so I have 27. Two factors of 27 that add to get negative 12. How about a negative 3 and a negative 9? X squared minus 3x minus 9x plus 27. I'm getting ready to group. Always grabbing the sign, sticking a plus between my quantities. And so I'll factor out an x. And then over here, I think I'm going to factor out a negative 9. Yeah, negative 9. And I'll be left with an x minus 3. I'll have an x minus 3 and an x minus 9. There we go. Okay. Okay, problem C, same type of problem, only this time there's a negative in the back, and that'll change things a little bit. I'll have a 42. I don't like to work with a negative 42. I just like to think about it's going to be a subtraction problem. I'm going to need to subtract to get negative 11. Well, I'm just quickly 1 and 42 2 and 21, 3 and 14. Ooh, that's going to work. So I'm going to go 3 minus 14. So I'll have x squared minus 3, plus 3x minus 14x minus 42. Looks like it's time to group. Stick that plus between those quantities. X times the quantity of x plus 3. I'll pull out a negative 14, x plus 3. So I have an x plus 3. I'll be left with x minus 14. There we go. I'm making it look easy, but the reality is it is easy. You just basically follow the same patterns each time. As you get used to working with factors, then it becomes easier and easier to do this. Okay, this one's a little more complicated. I'm looking for a GCF and I'm not seeing one. Okay, so I'm going to multiply 12 times 35. Well, let's see here. If I triple 35, I get 105. If I double that, I get 210, 420. I believe that the product is going to be 420. Okay, yeah, 420. So I'm going to need two factors of 420 that subtract to get negative 32. Well, I know 1 in 420, they're too far apart, right? So I'm going to just try to be smart here. And I know 4 is going to go in. I know 6 is going to go in, but 6 is only going to go in 70 times. They're still too far apart. 7 is going to go in 60 times. It's not even close to being 32 apart. I'm not going to worry about those beginning ones. How about 10? Well, 10 is going to go in 42 times, and those are 32 apart, aren't they? So you see I didn't list out all the factors. I'm trying to be smart in my approach. Okay, I want to work smart, not hard. Now, I need to subtract to get negative 32, so the problem will be 10 minus 42. So I come up here, 12x squared plus a 10x minus a 42x minus 35. Time to group. Put my plus in between. And now I'm going to GCF. Looks like here I'm going to pull out a 2x and I'll be left with 6x plus a 5. And here I'm going to pull out a negative 7, I believe, and I'll be left with a 6x plus a 5. And look at that. A 6x quantity of 6x plus 5 times the quantity of 2x minus 7. Now, I don't know about you, but I like to work smart, not hard. I don't want to list all the factors of 420. I will if I have to, if I can't see it, but I'm going to use a smart approach. Okay. Number 20, very similar type problem. Got a plus in the back with a negative. I know both quantities are going to be negative because I'm going to add to get negative 17. All right, so 20 times 3 is 60. And I need two factors of 60 that subtract to get 17. What's that you say? 20 minus 3. There you go. See if you're paying attention to what you're doing. Sometimes it's easy. All right, so I'm going to do, I did that wrong, didn't I? It's easy, but not when you do it wrong. It's 3 minus 20. There we go. All right, so we have 20x squared. And I'm going to go with a minus 20x plus a 3x and plus 3. And now it's time to group. Put that plus sign in there. Pull out a 20x, left an x minus 1. Pull out a 3, be left an x. Oh, I think I have a mistake here. Yeah, I do have a mistake. I got so excited about how easy this was going to be, I've made a mistake. Okay. Okay, my mistake was I need to add to get negative 17. I subtracted. Hopefully you caught it. All right, so I need two factors of 60 that are about 17 apart. 1 and 60 is not going to work. 2 and 30 is not going to work. 3 and 20 are 17 apart, but they won't add. 4 and 15. That's not going to work. No. 5 and 12. There we go. 5 and 12 are going to work. The problem would be a -5 and a -12. All right, let's try this again. Sorry about that, ladies and gentlemen. Okay, so minus 5x minus 12x plus 3. All right, so now I'm going to group. And going to GCF. Looks like I'm going to pull out 5x. I'll be left with a 4x minus 1. Here, I think I'm going to pull out a -3. And I'll get a 4x minus 1. And that looks a lot better. Quantity of 4x minus 1 times the quantity of 5x minus 3. And there we go. All right. Letter F. Before I actually go and do it, I noticed something right off the bat. I've got a perfect square. 4. I've got a perfect square here, 5x. If I multiply them together, I get 20x doubled. I've got 40x. This is a perfect square trinomial, ladies and gentlemen. 5x and a 4, 5x and a 4. Need two negatives. Boom, boom. There we go. All right. G, it's a binomial. Perfect square? Yep. Perfect square? You bet. Except there's a GCF hiding in there, isn't there? I'm going to pull that GCF out first. I believe the GCF is going to be 16. And then I'm going to have 4x squared minus y squared. Now I'm going to check. Perfect square? Sure, 2x. Perfect square? Yep, y. Okay, 16 times the quantity of 2x plus y times the quantity of 2x minus y. And there you go. Okay, letter H. Perfect square? Yep. Perfect square? Yep. You see any subtraction? I don't see any subtraction. This is prime. This cannot be factored. It can't. If you were thinking, oh, no, wait, Mr. Lawrence, you're wrong. It's x plus 3 times x plus 3. You go ahead and FOIL that, and you'll realize you don't get x squared plus 9. So this one is prime. We cannot factor it. Okay, later on we'll learn how to solve an equation that has a binomial like that. But as of right now, we don't know how to do it. And in terms of factoring, it is prime. Okay, that's the video. Mr. Lawrence signing off. Have a good night, everybody.